online, I may do that every now and then because there's really nobody there. But those that are online can actually participate in the class as well. Okay. And also, if you watch it, give me feedback like, why are you wearing that shirt? You should be louder. I don't like this, or I really like this. Thanks for doing it, blah, blah, blah. But right now it's live. And if you want to go on your phones, go to Professor Grocha YouTube page and watch it live right now. Okay. And if you want to try to comment, let me know if that works, all that. Okay. So I'm going to start class with a quick little video. Remember, we're not going to learn just from me, but we're going to learn from each other. So here's a little video about working together.
And tonight, Steve Hartman proves that best friends come in all shapes and sizes. Here's tonight's Assignment America.
When elephants retire, many pack their derms for the Elephant Sanctuary in Tennessee. They arrive here one by one, but stay here two by two.
Every elephant that comes here searches out someone that she then spends most of her time with. What are you doing?
Sanctuary co-founder Carol Buckley says it's like best girlfriends.
It's like us, you know, somebody that they relate to, they have something in common with. Oh, hello, how are you?
Debbie has Ronnie.
Best buds, these two.
Misty can't live without little Lori. And perhaps the closest friends of all.
Tara and Bella, of course.
There's no other elephant around here?
That's Tara.
Just these two.
And this is Bella.
This is her friend, and her friend just happens to be a dog and not an elephant.
That's hilarious.
Bella is one of more than a dozen stray dogs that have found a home at the sanctuary. Most want nothing to do with the elephants and vice versa. But not this odd couple. They are absolutely inseparable.
When it's time to eat, they both eat together, they drink together, they sleep together, they play together.
Tara and Bella have been close for years, but no one really knew how close they were until recently. A few months ago, Bella suffered a spinal cord injury. She couldn't move her legs, couldn't even wag her tail. For 3 weeks, the dog lay motionless up in the sanctuary office.
And for 3 weeks, the elephant held vigil. 2,700 acres to roam free, and Tara just stood in the corner.
To me, it really was she was concerned about her friend.
Then one day, co-founder Scott Blake carried Bella onto the balcony so she and Tara could at least see each other.
And Bella's tail started ringing, you know, and we had no choice but to bring Bella down to see Tara.
They visited like this every day till Bella could walk.
Wow.
Today, their love and trust is stronger than ever. Bella even lets Tara pat her tummy with her foot. They harbor no fears, no secrets, no prejudices. Just two living creatures who somehow manage to look past their immense differences. Take a good look, America. Take a good look, world. If they can do it, what's our excuse?
Okay, so it's a nice little video. Actually, if you follow up with the video, the elephant actually stepped on the dog. I'm just kidding. No, they're fine. All right, so last class was a little bit boring because we basically did the entire what's the class about, all that stuff. Today, we actually get started. I do apologize again and again that the class notes are not there. They know they're working on it. And so hopefully, I'm sorry?
It's there now.
It's there now? Like literally in 24 hours, it's there?
Yeah, I got it this morning.
Perfect. So there's a ton of them?
Yep.
Okay, so I don't apologize at all. Go get it. So what happens is we're going to go through. If you don't have any notes today, don't worry. Just take a piece of paper out and we'll just kind of go through it. But remember, I'm not teaching chapter 1. So real quickly, literally real quickly, I'm going to walk through the notes in chapter 1. You have blank notes. Where are the answers to all the notes? In black. Okay? So why am I not going over chapter 1? Remember, chapter 1, I'm trying to get you used to the computer. I want you to read the chapter on your own. I want you to, you're on video. Ooh, there's video going on. Let's see. No. As long as you don't mind. So chapter 1 is vocabulary. Chapter 1 is some information, but it's really for you to learn on your own, do the homework, do the quiz. I'm going to be honest with you. I'm a little lenient on the chapter 1 homework. Like if it doesn't work, let me know. I'll help you out. If the quiz explodes, I'll help you out. But mess up in chapter 1, I'm not lenient too long. Does that make sense? So if you have any problems in chapter 1, just let me know. I'll help you. We'll fix it right away. Mess up in chapter 1 so you're good on the other ones. Chapter 1 counts. Everything counts. we okay? So in chapter 1, you're going to talk about variation, you're going to talk about data, reading a table, and you'll notice in the notes, I basically outlined the book, but I add a lot of my own stuff. So I did some research. The heaviest baby ever born was 23 pounds, 12 ounces. It was so large because the baby's mom was 7 feet 5 inches tall. The smallest baby was the smallest baby to live was only 10 ounces in Florida. Okay, so I add information. You're going to learn about variables. You're going to learn about there's numeric variables, which are numbers, categorical variables, which are categories. A couple examples to try. It's very kind of interactive. Coding you'll learn about, stacked and unstacked. You're going to learn about a two-way table, being able to read table. Like just real quick, looking at this, how many females always wear their seatbelt? Females always. 7. Okay, so you'll be able to read a table, a bunch of questions, answers to everything. And then there'll be some activities to do, like if you do the notes. Real quick, this is little things that I worry about. So this tells you how many people get injured from bowling. Okay, so 21,133 people got injured from bowling, but there's 43 million people that bowl. So if I want to find out what % of people get injured bowling, what do you do to those two numbers? Divide them. So what I want you to do right now, take out your calculator, divide them, and change to a %. It should be something we all know how to do, but we make little mistakes. So go from a decimal to a %. Decimal to %. And I do have 3 extra calculators, so someone needs to borrow one. 1, 2, 3. 1, 2, Okay, so again, you're going to do this at home, but just to give you a little quick introduction, what you're going to do is you're going to take 21,133 divided by 43,900,000, and you get this. Okay, so there's problem number 1. Problem number 1 is when you look at your calculator, it gives you this weird number. We know it's not 4.81. Okay, what's going on with this number? Yeah, there's this e -4. It's actually scientific notation. It's like times 10 to the -4. That means start at the decimal and move how many places? 4 to the left because it's negative. So again, we're learning about our calculator and learning about decimals. It's not 4 zeros, it's 4 movements to the left. So what number would that be? 0.123, let's just say 48. Okay? So first of all, that is what you get as a decimal. Okay, so it's super small. So number 1, you have to know a little bit about your calculator. Are we okay with the decimal now? Now, all of you know how to go from a decimal to a %. You all know it. If I told you 0.25, 0.25 is what %? 25%. Are we okay with that? So all you do is move the decimal over 2. You see this, and it looks like it's the hardest thing in the world. But you always do what? Move it 2 places. I know it looks weird, but it's always the same. So you move it over 1, 2. This will be 0.048%. Are we okay with that? And again, it's those little mistakes you make, especially in my stat lab, where you're like, I don't know why I got it wrong. You probably forgot a 0. You didn't move it over enough, little things like that.
On the homework, it says to times it by 100.
Yeah, timesing by 100 is the same thing as moving over 2. Perfect. That's a good way to look at it. Okay? So again, when she's doing her homework, do that. Okay? So little things like that is what I worry about, and this is going to give you practice. Okay? Again, other stuff in chapter 1, you'll learn about causality, treatment variable, outcome variable, read through all that, treatment group, control group. And it's kind of weird. All this stuff will come up again in chapter 6. So anecdote, placebo effect, observational study, what that is, confounding variables. You're going to read chapter 1. You're going to learn all that. A lot of vocabulary, controlled experiments. Sample size, random assignment, bias, blinding, double blind. A good experiment has a large sample size, it's controlled and randomized, double blind has a placebo if needed. There's an example reporting stuff out, extending the results, statistics in the news, and example. Okay, so that's chapter 1. That's why I feel comfortable you could do that on your own. Okay? Chapter two, we're going to do together. Okay? And to be honest, your first test really covers chapter 2 and 3. And this is it. So if you have your notes, take them out. If not, just take the stuff I write. That's the stuff you write. You'll have your notes later. Okay? So what we're going to look at is visualizing variation in numerical data. So the distribution of a sample is basically the way you organize the data. If I throw up a bunch of numbers, it's not going to make any sense. We like the numbers organized so we can take the numbers, analyze it, and kind of pull some information from it. Okay? If I use the word frequency, frequency means count. How many times? How many times? Okay? There's a bunch of ways of doing this. The first one we're going to learn is something called a dot plot. Now, the way we do class is this. I could have a pre-made example. And if I have a pre-made example, it always looks the same. It's a pre-made example, it always looks the same. And that's not fun. It's not data. So I'm going to ask you to give me data. I'm never going to ask anything personal. If you don't want to answer, just say pass. You don't have to answer. But I like to work with real data. And with real data, maybe it's messy, maybe it's pretty. I don't know. That's real life. That make sense? So if you never want to answer, don't. But again, it's real data. And every class is different. So this one says, how many hours of sleep do you get a night? So think about it. An average night, how many hours of sleep do you get? So we'll start here. How many hours? 8. 8. Okay. 9. 5. 6.
8.
8. 6. 8. 7. Up front.
7.
7. 9. 6. Up front. 7. 5. 6. 7. Back row.
6.
6.
7.
7 and 4 and one more. 7. Okay? So what we have right now is a bunch of jumbled numbers. Okay? I can't really tell what's going on. Looks like there's a bunch of 7s. Looks like there's some 6s, but it's all jumbled and it's difficult to understand. Are we okay? So one way to organize the data is called the dot plot. What we're going to try to find is the distribution of the data and the frequency of each hour. Okay, so those words coming up again. So our title is going to be hours of sleep for the Monday, Wednesday, 9 a.m. class. And then you'll notice we have this dark bar. Okay? That bar is where we're going to put all of our numbers. That's where we're going to put all of our numbers. So what's our lowest number? 4, and it goes up to 9. And probably we'll go by ones, right? So looking at the data, we have hours of sleep. We have 4, 5, 6, 7, 8, 9. And the reason why it's called a dot plot, is because every piece of data, we're going to put a dot. So the first number we have is an 8. Okay? So above the 8, we're going to put a dot. All right? Above the 9, we're going to put a dot. Now to keep this organized, all the first dots are going to be aligned. All the second dots are going to be aligned, so forth and so on. So we have 5, 6. So we'll put a dot on the 5, dot on the 6. We have another 8, which goes above, and another 6, which goes above. And again, do your best to try to keep them all aligned. Questions so far? Again, help each other. Do the rest. It should look something like that when you're done. It's 24. About right. Okay? So take your time, kind of go over it. And once you have it, look at what we've done. We've created a distribution of the data so I can see the frequency of every single hour. Look at what we had before, a bunch of jumbled numbers. I couldn't really tell what's going on. Once we organize the data using a dot plot, now we can look at the distribution and make some analysis. So what do you think? Where do most people sleep? Like 6, 7? Most people are on 6 or 7. Few people under that, 6 people over that. Okay? How many hours do they say you're supposed to sleep? 8. So if you're supposed to get 8 hours of sleep, most of us are not getting 8 hours of sleep. And they actually say, I heard something recently, that if you get under 6, you're more likely to get sick. Okay, so if you don't get enough sleep, you're going to get sick, basically. Does that make sense? Not too bad? Okay, and people like a visual. They don't want to stare at a bunch of numbers. People like pictures to be able to understand, to be able to analyze data. Okay, so that's number 1. Number 2. Another thing we can make is something called a histogram. Another thing we can make is something called a histogram. Now, a histogram kind of looks like a bar chart, but it's a little different. So let's say we're part of the Elks or the Moose Lodge or the Rotary Club, and we're trying to figure out how old our people are. So we start making these bins. So if you're between 40 and 44, we have 2 people. If you're between 45 and 49, we have 6 people. 50 and 54, we have 13. 55 to 59, we have 12. 60 to 64, 7. 65 to 69, we have 3. So those are our little bins that we put people in, okay? But again, I want to see a picture. So to get a picture of this data, we really have 2 things going on. We have the age and we have the count. So I'm going to put the age, so I can put it on one screen. I'm going to put the age on the x-axis, and I'm going to put the count on the y-axis. And I want a picture of what's going on. Now, my youngest person there is 40, and my oldest is 69. So you'll notice I'm going to make the cutouts a little different, but you'll see why in a minute. So I'm going to put 40, 45, 50, 55, 60, 65, 70. Now, as you're writing that, you're probably wondering, where's the 44? Where's the 49? We'll take care of that in a second. So on the x-axis, we're putting 40, 45, 50, 55, 60, 65, and 70. The reason why I don't have the 44 and the 49 is, if I'm between 40 and 44, I'm in the first group. As soon as you turn 45, what happens? You're in the next group. Okay, so you fall directly from one bin to the next. There's no in-between bins. It goes from one to the next to the next. Okay? Now, for the y-axis, we're going to look at our count. So for the count, we have 2, 6, 13, 12, 7, 3. Well, our lowest is 2, so maybe start with 0. And our highest is 13, so maybe go up to what? 14. And if I'm going to go from 0 to 14, I probably don't want to count by 1s. What do you want to count by? Probably count by 2s. So based on the data, we're going to make our scale. Okay? Now, we're missing the bars. So how many people are in the first group? 2. So we start at 40, we go up to 2, and we go back down once I get to 45. Because as soon as you turn 45, what happens? You're in the next group, which has 6. So I go up to 6 and go down. What happens when you turn 50? There's 13. Then there's 12. Then there's 7. Then there's 3. Okay, give me a second to kind of get caught up, see if you have the same thing. Okay, so again, before we had a bunch of numbers kind of looking at it, now I can kind of see where do most people fall? 50 to 60, 50 to 55. Does that make sense? And you kind of could see that before, but it's nice to have a picture of it. It's nice to have a picture of it. Are we okay? Now, let's say we get a knock on the door. Somebody wants to join. No problem. Come on in. I'm actually working on this right now. Which group do you fall in? And they're like, I don't fall in any of these groups. I'm actually between 75 and 79. So we add that guy down here, 75 to 79, and one person joins. So you notice he's not in any of these groups, and he's actually not in that. He's actually in this group way down here. He's in this group way down here. Okay? That guy is outside the data. That guy is outside the data. What would we call that guy? Super, super old. Okay? He would be considered an outlier. How do you know he's an outlier? Here's the flow of data, flow, a break, and then somebody shows up. That gap shows nobody's here. Anything beyond that gap would be like an outlier. And there's an official definition of an outlier. We'll get to that later. But visually, that's a quick way to identify an outlier. Are we okay? Not too bad? Now, this can be a little difficult to make. You got to pick up bins and you got to put them in and you got to draw a picture and all that stuff. Well, you have a fancy dancy calculator. Do you think it can do that? Yes. For $100, it better do that and your laundry, right? So what we're going to do is we're going to use the calculator. For most of you, this is the very first time you're using the calculator. So we're going to go super, super slowly. Please help each other. I'd like to all stay together. What happens is somebody messes up and then they're afraid to raise their hand. It is much, much easier for me to stop than to back up. Does that make sense? So let's all stay together. Please don't hesitate to ask. I don't bite. I'll come over. I showered. I don't smell bad. So just raise your hand. But I would like to all stay together. And what we're going to do, we're going to do over and over and over again. So you want to get it now. Are we okay? Question. I just had the 3, yeah. So maybe just kind of work together. Do you guys have one? Okay, so what about someone that has, do you guys, yeah, that'd be good. Perfect. Okay, they're good. Does everybody have one? And then you need one? You have one, everybody has one? As long as your partner has one, kind of share it. Okay? So what I've done here, and again, if you're one of those nervous type people, don't be. What you have in your class notes is literally step by step and what buttons to press. So when you go home, if you forget, it's all here. So don't stress, don't stress, don't stress. Are we okay? So just follow along. Don't worry about the directions right now. Just follow me. Just follow me. Okay? So we took some test scores, and I would like to make a histogram. Normally, we'd have to make up bins, decide where the cutoffs are, put them in. We're going to do it totally in the calculator. Okay? So step one is we have to take that data and put it in our calculator. Are we okay? But the very first step is we have to make sure we have a clean calculator. We have a clean calculator. So what does a clean calculator mean? Go to your calculator. And again, just some basic stuff. You know that that's the on button, right? And if I hit second on, what does it do? Off. So you have 2 sets of buttons. You have the buttons that you can push that are like the face value ones. And then if you hit second, you get all the blue ones. And there's menus and stuff within there. So there's a ton of options in here, okay? So the very first thing we want to do is this is the home screen. No matter what happens, no matter where you are, if you want to get back to the home screen, you go to quit. See where it says quit? To the blue or yellow? To quit, you hit second mode. So if you ever feel like you're lost, you don't know where you are, just hit second mode. That gets you back to the home screen. That's the best place to start. It's the only time I'm ever going to tell you to quit. It's on the calculator. Okay? Now, to start and make sure you have a clean calculator, everybody push y equals on the top left. Y equals top left. Okay? when you push y equals, if you have a clean calculator, that means there's nothing in y1, so I'm going to get rid of that y1. Also, see where it says plot 1, plot 2, plot 3? Some of you may have them highlighted. We don't want them highlighted. So if you have it highlighted, go up to it, enter, enter, and you unhighlight. So take a second, make sure there's nothing in y1, nothing in y2, nothing in y3. Make sure your plot 1, plot 2, and 3 are not highlighted. If this doesn't work, I would bet money it's because something is highlighted or something's in there. Okay? That's most of the time what the issues are. Okay? Just checking if I told some people to go look. There's one person watching. Okay? Everybody have a clean calculator? Okay. Now, there's your data, and the question is, how do I get that data in my calculator? Okay? How do I get that data in my calculator? So, nice and slowly, everybody push stat. Stat. S-T-A-T, top middle. Stat. Once you push stat, you should see edit, calc, test. Everybody see that? Push number 1 for edit. So stat, number 1 for edit. Stat, number 1 for edit. Now, when you go there, you should see list 1, list 2, list 3, list 4, list 5, list 6. There are 6 lists that we can use to put our data in. Are we okay? Now, I have stuff in my lists. If yours are blank, you're good to go. But I'm going to show you how to get rid of stuff. So just watch, don't do it. Okay? Just watch. So notice in list 1, I have all those numbers. There are 2 ways to get rid of the numbers. I can hit delete, 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 and delete each number. But are you noticing this is taking a little while? But I can delete each number. So step 1 is you can delete the contents. Delete the contents. But you notice this is taking a while. So I just hit delete, 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 delete. But eventually, they're all gone. So that's one way. Don't do it, just watch. Don't do it, just watch. The faster way is to go up to the top of the list. Don't hit delete. Clear, enter. So you can clear a list or delete the contents, but don't what? Delete the list. Because what happens is it's gone, and it's gone forever. Until I come over, and then I have to fix it, and I have to insert it, and then you owe me Starbucks, and I like caramel macchiato skinny hot, grande. Okay? So everybody have a clean list? List 1, list 2, list 3? Everybody have that? Now, we're going to use list 1. In the beginning, we'll just use list 1, but we'll play around with it later on. But I want to put that data in list 1. Order doesn't matter. Order doesn't matter. So the first number is a 90. So I'm going to hit 90, enter. Oops. Go to list 1. In list 1, 90, enter. 95, enter. 80, enter. 85, enter. 70, enter. 79, enter. 93, enter. 100, enter. 88, enter. So when you're done, there should be 9 numbers in list 1. And the biggest mistake, which is so weird, it's not the calculator, it's you type in the wrong number. If you type in the wrong number, everything's wrong. So when you're done, go back and check those 9 numbers. Go back and check those 9 numbers. Any questions so far? Okay, so step 1, put the data in the calculator. Step 1, put the data in the calculator. We're all good? Okay. Step 2, I have to tell the calculator that I want a histogram. I have to tell the calculator that I want a histogram. So if you go to second y equals for stat plot, second y equals for stat plot, second y equals for stat plot, notice you have plot 1, plot 2, and plot 3. Plot 1, if you want to see one picture. Turn on 1 and 2, you see 2 pictures on top of each other. Turn on 1, 2, and 3, you see 3 pictures on top of each other. Are we okay? So we only want 1 picture, so we're going to go where? Plot 1. Okay, so everyone go to plot 1. Right now, is plot 1 on or off? Is plot 1 on or off? Off. How do you know it's off? Off is highlighted. So push enter on top of on. Push enter on top of on. Then push down. When you push down, move left and right. When you push down, move left and right. When you push down, move left and right. There are 6 pictures that we can do. Okay, of those pictures, which one do we want? The third one. So go down to the right, push enter on the third one. The third one is a histogram. That's what I want. So to make sure we're all together, plot one on, and you've pushed enter. If you don't push enter, these options are different. Push enter on the histogram. Are we okay? Push down, down. And then it's asking, where is your data? Okay, and where is our data? List 1. But if you look at your calculator, if you look at the 1, 2, 3, 4, 5, 6, those are the lists. So to hit list 1, you have to hit second 1. For list 2, second 2. So just play around a second. Hit second 2 for list 2. Clear. Second 4 for list 4. Clear. When you're done, just make sure it says list 1. But I'm going to give you multiple lists. So don't always use list 1. Be able to use all lists. We okay? So on histogram, list 1. We good?
Do you have a clear?
Wouldn't you have it?
Yeah, not list 2.
Oh, no, you good. Yeah, perfect. Or just you can hit clear or delete. Clear. There you go.
Okay.
Now, the last thing is frequency. You're never, ever, ever going to miss with frequency. Leave frequency alone. Frequency is only 1. And the reason why I say leave it alone is if you go to frequency, it's automatically in alpha mode. You have to hit alpha 1 to change it, so it's kind of annoying. So leave frequency alone. Are we okay? Step 1, put the data in the calculator. Step 2, tell the calculator you want a histogram. Step 3 normally is the window, setting up the window. We're going to save that for later because we're already doing a lot of stuff. So to automatically do the window, you're going to hit zoom 9. Don't do it yet, but you're going to hit zoom 9. The problem with zoom 9 is you can't do it here. So move up, 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 move up, up, up where it says on. The reason why you can't do zoom 9 here is because it gives you more options. And again, it's annoying. So move your cursor up here. Find zoom on the top row, zoom, top row, and then hit 9. What zoom 9 does, it's good and it's bad. What zoom 9 does is it automatically does the window for you. It makes the window for you. No thinking involved. The bad part is it does whatever it wants. It does whatever it wants. So kind of look up and don't do anything. Don't do anything, just watch. If I go to window, they went from 70 to 107.5, counting by 7.5s. You probably wouldn't have done that. You probably would have gone 70 to 75 or 70 to 80, right? And they went from negative 0.9 to 3.51. So it's not great, but it does give you a nice picture. And it gives you a consistent picture. So on the test, if I tell you to hit zoom 9, all of your pictures will be the same. So that's why we do it for now. Okay? Does everyone have that picture? Anybody not have that picture? Okay? If you have the notes, it's on the bottom of the page. If you don't have it, draw it. If you don't have it, draw it. So if you're writing in your notes, draw that picture. So what we have is a histogram. What we have is a histogram. But the next thing we want to do is we want to label the histogram. The next thing we want to do is label the histogram. So if you look on the top row, does everyone see the trace button? Trace button. Push trace. Push trace. When you push trace, it gives you information about each column. So which column are we talking about right now? The first one. How do you know? It's blinking. The first one's blinking. Then it gives you these numbers. This bar starts at 70, minimum 70. It goes to 77.5. And how many tests fall in that bin? 1. So here's how you label it. So on my picture here, it starts at 70. So 70 is at the first line. it ends at 77.5, because these are all test scores. And how many test scores fall in that bin? That goes on the y-axis. Okay, so again, it gives you the numbers. You have to put it in the right spot. So it starts at 70, it ends at 77.5, and there's one test score that falls in there. Are we okay? How do I go to the next bar? Push to the right. How do I go to the next bar? Push to the right. If on your calculator you push to the right, on the right side, and then says the second bar starts with what? 77.5, ends at 85, and how many in that bin? 2. Okay, so I put 85 here, I put 2 there, and then keep on moving to the right, keep on adding. And again, if you need help, raise your hand and work with your neighbor. Please do not be shy. We're all in the same boat. This is new for everyone. So you are going to be asked to make a histogram and label. Make a histogram and label. Okay? Questions so far? Everybody got it? Now, if you look at this picture, something's weird. What's weird? Look at the test scores and look at the picture. Look at the test scores and look at the picture. What's weird? Yep. Yeah, where the heck is 107.5? Nobody scored a 107.5, so that's kind of weird. Why is it 107.5? Well, I'll help you out. Don't go to the last bar. Don't go to the last bar. Go to the second to last bar. Don't go to the last bar, but go to the second to last bar. That second to last bar goes from what to what? Ooh, look what he said. If you don't see it, let me help you. Let me really help you. What does it say? Less than. So 100 does not fall in the second to last bin. Where does 100 fall? In the last bin. And how many hundreds do we have? One. Just one. Are we okay? So remember those cutoffs. As soon as you turn 50, you're in the next group. As soon as you get 100, you're in the last group. Does that make sense? Now, here's the fun part. Any questions so far? Okay? This is my favorite part. Any questions? No questions. Are we okay? I'm going to do something. I'm going to come back to this. I'm going to see if you remember it. We'll have a lot of questions. Okay? Let's see if we can remember this. All right. So flip the page. Let's do another one. Another thing I'm going to teach you is something called a stem plot. Another thing I'm going to teach you is something called a stem plot. Another name for stem plot is called a stem and leaf plot. A stem and leaf plot. Okay? Stem plot, stem and leaf, same thing. Stem plot, stem and leaf, same thing. Okay? The reason why it's called stem and leaf is there's two parts. There's a stem and there's a leaf. A stem and a leaf. And I'll explain what it is. But I need to get some data from you. Okay? So what I'd like you to think about is how many minutes does it take to get from your house to Osceola campus? From your house to Osceola campus, and I want exact measurements. I don't want like, it takes 10 minutes, it takes 20 minutes, 30. I want like 19, 17, 18, and it's okay to repeat. It's okay to repeat numbers. It's okay to be 20, but try to think about exact. I don't want all 10, 10, 10, 10, 10, 5, 5, 5, 5, 5, 20, 20, 20. Okay, so how many minutes does it get from your house to campus, normally?
23.
23. Okay.
32.
32.
11.
11. 25. Okay, in front.
18.
18. Next. Next. How many minutes from your house to here? Sure.
19.
19.
35.
25. Sorry? 32. 25. No problem. Again, I'm not going to check. I'm not going to go to your house. I'm sorry?
45.
45. Where do you live?
I live like over by Disney.
Oh,
Like
wow.
right by Disney.
Okay, so like on that end. 28. So you hear the fireworks every night?
Yes, I see them too.
You see them every night.
17.
17.
18.
18. 24.
16.
16. 16.
26.
26. What's that?
43.
43. Where do you live?
27.
Point Siena. But it's pretty soon. You're on the campus right there. Opens in fall.
16.
16.
13.
13. 20. 22. One more. Maybe we lost 20. Okay. And let's say mine is 0. I live in my office. And let's say 100. Okay. So what we have again is a bunch of jumbled numbers. Now here's the deal. We are Valencia College. We used to be Valencia Community College, and the whole point of a community college is this. We're supposed to be near you. We don't want you driving all over the place, right? That's why we have campuses all over. And if we don't have campuses, then there's Polk, and then there's Brevard. The goal is we want to bring education to you. Does that make sense? So probably we want you driving about 20, maybe 30 minutes at most. We don't want you driving an hour. The most I ever had a student drive was an hour and a half. It was like an hour and a half or an hour and 40. He came from Sebring 2 times a week just to have class here at Valencia, right? So again, we don't want that to happen. We want to be in your neighborhoods. Now, if we're not in your neighborhood, something's wrong. We're either not in the right place or we need to build another campus. An example would be Point Siena, okay? Point Siena physically is not that far away from us. What's the problem? Traffic. If you ever get stuck on Pleasant Hill in 792 at the wrong time, just sleep there because you're not going anywhere, right? So we have to really fight for a campus there because miles, it's not that far. It's really not that far. The problem is if you get stuck in certain intersections, like one way in, one way out, there's a couple ways in. But the idea is that now we're going to be in the community. Now more people have access to education. Does that make sense? But let's see how we're doing so far. So the problem is we have a bunch of jumbled numbers. So one way to organize it is called a stem plot. We're going to do a regular, then we'll do a split. But we'll start with a regular. So what's the lowest number we have? 0. So what I'm going to do is I'm going to make a zeros row. What that means is because I have a stem and a leaf, I have 2 parts. So every number has to be a 2-digit number. So how do you turn 0 into a 2-digit number? 0, 0. Okay? So anything that starts with 0 would be in the zeros row. Anything that starts with 0 would be in the zeros row. Do I have anything else like 1, 5, 7, 9? No. But if I did, it would be in this row. 0, 0, 0, 1, 0, 7, 0, 9. But I don't have anything else in that row. What would the next row be? 1. And what that represents is any number that starts with 1. So of all my numbers in order, what starts with 1? 11. So on the left side is 1. What's going to be on the right side? Just the 1. Just the 1. Because this stands for 0, 0, 1, 1. So anything that starts with 1, I already have the 1 taken care of. What's the next number? 13. So beside it, I put a 3. And again, this represents 0, 0, 11, 13. Are we okay? We're grouping all the 1s together. What will be the next one in order? Now, how many 16s do I have? 1, 2, 3. Let me check these off. Let me mess up. So we have that. We've done that. So we have 1, 2, 3. 3 16s. So I'm going to put 6, 6, 6. Well, that's on you guys. I didn't put that. Okay. Are there any more 1s? 17. So I put a 7. Anything else?
18.
There's an 18. How many? 2 of them. So 8, 8. Anything else?
19.
9. So again, to recap, I have 0, 0, 11, 13, 16, 16, 16, 17, 18, 18, 19. We okay? What would be the next row? 2s. In order, keeping everything aligned, what would be in the 2s?
22.
First one.
0.
Good. We have a 0 to represent 20. What else?
22.
We have a 2 to represent the 22. Again, keep everything aligned. A 3 to represent the 23.
25.
How many 25s?
3.
One.
24.
Oh, there are 24? Yep, there's a 24. Thank you. And then 1, 2, 3 25s. Anything else in the 20s? 26. 28. Anything else? All right. What's the next row? 3s. What would go in the 3s?
32.
How many of them?
2.
We got 2 32s. What else? Anything else 30s? Okay. What's the next row?
4.
What goes in the 40s?
46.
We have a 43 and a 45. Anything else?
No.
Have I done all the numbers? No, I'm missing something. 100. So the question is 2 things. 1, how do I write 100? And 2, where do I put it? So first of all, how would I write 100? 10, 0. We good there? Now, you tell me visually what gives you more information. Should I put 10, 0, or 5 blank, 6 blank, 7 blank, 8 blank, 9 blank, 10, 0? Which one visually gives you more information? Blanks or no blanks? Blanks. So let me tell you why. 5, nothing. 6, nothing. 7, nothing. 8, nothing. 9, nothing. 100. Oops, off the chart. Now, why visually does that tell me something?
So that you see.
Yeah. Nobody drives 100 minutes to come to Osceola campus. It's very unusual. That is clearly an outlier. That is clearly an outlier. Does that make sense? So what happens is nobody's here. Visually, I see a blank. That's not normal. Okay? And again, am I going to move a campus for one person? Probably not. So I'm really going to look at the majority. Most of you are traveling how far? 10 and 20. Is that what we're supposed to do? So are we at a good location probably? Yes. Does that make sense? Now, this is called a regular stem plot. A regular stem plot. Okay? Useful, all that wonderful stuff. We can also make a split stem plot. A split stem plot. Now, let me explain the difference between a regular and a split. I got a lot of 1s and I got a lot of 2s. But is it the lower ones or the upper ones? Is it the lower 2s or the upper 2s? Which one has more? I don't know. So a split stem breaks the data. So with a split stem, kind of write this small. We're going to put 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. What have I done with the data? I split the data. Now notice I didn't put 100. Why do you think I'm avoiding 100 right now? It's an outlier. I have a ton of blanks, so I'm skipping 100, right? If on the test I asked you for a split stem, you'd have to put all of them. But for right now, I'm skipping 100. Are we okay? Now, the question is, what would go on the lower and what would go on the upper? What would go on the lower and what numbers would go on the upper? What do you think? So 0 to 5 or 0 to 4? What would be fair? If you did 0 to 5, let's count that. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that fair? No. So what should go in the lower? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Does that make sense?
I don't even know what you're talking about. You like lost.
No. And that's great. And that's exactly what you're supposed to do. See those numbers? Well, you're not supposed to be lost.
You're like 1, 2, 3, 4.
No, I know. Like, what is his fingers doing? But you see those numbers? I have to break them in half. So which numbers go in the bottom half and which numbers go in the upper half? Should I put a 9 in the bottom half? Probably not. The bottom half are the lower numbers. So I'm taking the data and I'm splitting it down the middle. I'm splitting it down the middle, okay? So if I take 0, instead of having one huge row of zeros, I'm gonna have 2 rows of zeros. But I'm trying to find the middle. So what numbers go in the lower? What numbers go in the upper? So what we've discovered is that the lower numbers will be anything like 0 to 4. The upper numbers will be 5 to 9. Let me explain what I mean. So in my zeros row, I only have a 0. Will that go in the lower or will that go in the upper? Where does 0 fall? 0 to 4 or 5 to 9? In the lower. Do I have anything in the upper zeros? No. Now this will be a little bit easier. Let's look at the ones. Do you see all those ones? I'm going to break it up. Will 1, this number here, go in the lower one or the upper one? Lower one. What about the 3? Lower one. What about the 6? All the rest would go in the upper. Okay, so let me explain that one more time. If you want to split the data into lower and upper, which numbers go in the lower? 0 to 4. Which numbers go in the upper? 5 to 9. And the most important part is, why would I do this? Looking at the ones only, are most people driving lower ones or upper ones? Upper ones. I couldn't answer that before. Now I can. Most people are in the upper ones. They're not driving 10 minutes. They're driving over 15. Does that make sense? Analyze a little deeper. What numbers would go in the lower 2s?
0, 2, 3, 4.
The lower 2s would be 0, 2, 3, 4. And then what? Uppers would be?
5, 5, 5, 6, 8.
Good. So as far as the 20s, let's zoom in now. As far as the 20s, they're about even. Okay? Now, as far as lower 3s, where would the 2 2s go? Lower. Do I have any upper 2s? Upper 3s, I'm sorry? No. And then as far as the 4s, the 3 would go in the lower and the 5 would go in the upper. So again, why am I doing this? Because most students travel how far? See how we digged a little deeper? Most students are what? Between 15 and 30 minutes. That's where most students are driving. We're not at your house, but 15 to 30 is not bad. Yep.
Are we gonna have to do these types of questions online for the homeworks?
The homework, you'll see when you start working on it, they'll ask you similar type questions, but they break it down pretty well. They'll explain it.
Okay, I was just gonna ask because like with the second 0, would you have to
Leave it blank?
Specific that to leave it
Yeah.
blank for 0. That had to be blank.
Yeah, it is blank because there's nothing in that one. And it also gives me information. I threw the 0 in myself, right? Remember that? The shortest one everyone really drives is 11. So 0 is kind of unrealistic. Nobody lives on campus. Maybe some cats, but that's it. Okay? But see how we can dig deeper? And do you see the difference between the regular stem plot and the split stem plot? Okay?
When you're doing, for each situation, it's better to do a graph.
On the test, you mean, let's say? I'm going to tell you which one to make. I'm going to say make a dot plot, make a stem plot, make a histogram on the test. In reality, some make sense and some don't. Because a dot plot, let's say I had concentrated numbers like we had, dot plot's great. If I had numbers all over the place, a dot plot makes no sense at all. Okay? And I'm going to blow your mind. Ready? Everyone looking at the board? Tilt your head to the right. What do you see? That's a histogram. All you did was make a histogram. That's all you did. Stem and leaf and a histogram are the same thing. You just made the bins by the stem. Does that make sense? So it's all the same stuff. Okay? Now, because we do all this, we have to start giving you some names. We have to start identifying using some vocabulary. Okay? So the first vocabulary is center. Now, we're not being specific. Later on, we're going to learn mean, median, and mode. Forget about all that for right now. Center just means middle. Center just means middle. Center, for right now, just means middle. What number is in the middle? Okay? So if I go back and look at my dot plot, there are 24 numbers. If I go back and look at my dot plot, there are 24 numbers. 24 numbers. Are we okay? What number would be the middle number? If there's 24, where would the middle be? 24 numbers, where's the middle? The 12th one. Are we okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What is the 12th number? That would be the center. It's just a number in the middle. It's just a number in the middle. It's just a number in the middle. Let's not overthink it or worry too much about it. Later on, we'll be specific. So the center of how many hours you sleep is what? 7. Okay? Let's do the same thing for the stem plot. How many numbers are there? 24. So which number would be the center? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What's the center number? 22. Okay? So the center number of how many minutes we drive to campus is 22. Are we okay with the concept of center? Don't get specific. We'll get specific later. Center is just the middle. What number is in the middle? Basically is what we're saying.
It's even if you go up or down.
That's later, yeah. We'll talk about median later, because then we'll have to talk about between and all that. Right now, just what's in the middle. We'll be kind of general. Now, spread, all it wants to know is what number does it start and what number does it end. Spread is what number does it start, what number does it end. So if I look at the dot plot, what is the spread of how many hours you sleep? 4 to 9. The spread will be 4 to 9. So how many hours do you sleep? 4 to 9. 4 to 9. Now for the stem plot, how many minutes we drive to school? What would the spread be? 0 to 100. 0 to the 100. The lowest is 0, the highest is 100. The lowest is 0, the highest is 100. So the spread is 0 to 100. Okay? How many minutes do we drive? Anywhere from 0 to 100. How many hours do we sleep? Anywhere from 4 to 9. Are we okay? The last one is outlier. There is an official definition of outlier, which we'll learn later, but there's a couple of things we have to learn. But for right now, outlier is anything outside the data. Anything outside the data. So if you look at the dot plot, are there any outliers? You can try to argue for, but does it still flow? Yeah. So I'm going to say no as far as outliers. But if somebody slept 2 hours, would that be an outlier?
Yes.
Yep. If somebody slept 12 hours, would that be an outlier? Yeah. So for right now, let's just say no. There's no outliers for the dot plot. None as far as outliers for the dot plot. And then the stem plot, do we have an outlier?
Yes.
Absolutely. What's the outlier? 100. That's a clear outlier. Nobody drives 100 minutes. And we had somebody that did. That's unusual. Okay? Now, as far as shapes, there are 3 basic shapes. Now, people confuse this all the time, so we want to be careful. But there are 3 basic shapes. Symmetric, skewed to the right, skewed to the left. Now, what everybody messes up is the word skewed to the right, skewed to the left. The skew is not the hump. The skew is the drag, the pull, the drag or the pull. Where's the drag? On the right. Where's the drag? On the left. This is skewed to the right, skewed to the left. People mess that up all the time. Okay? Now the hump is where most of the data falls. Most of the data falls. So let's just do a quick question. This is getting a 0 on your test. This is getting a 0 on your test. This is getting 100 on your test. What would you like the distribution of your first test to be? Symmetric, skewed left, or skewed right?
Skewed left.
Okay? If you said skewed to the right, you hate your classmates. You want to be the one kid with an A and everybody else fails. What you probably want the distribution to be is what? Skewed to the left, because most people did on the high end with a few people on the low end. Does that make sense? What do teachers want it to be? Symmetric. Most people fall in the middle, a few A's, a few F's, but most people fall in the middle because this is supposedly fair. Okay? Do you guys like the idea of grading on a curve? Do you like that? Do you like grading on a curve? You shouldn't. Okay? Grading on a curve means the teacher wants symmetric. The teacher wants symmetric. Now, the reason why you like grading on the curve is what most of the time what happens is everybody what? Everybody fails. Now, does that look symmetric to you? So how can I move that hump over? Everybody gets what? Everybody gets points, so that hump moves over to make it look symmetric. Does that make sense? But if you truly believe in a curve, what should happen when everyone gets an A? You should take points away. Do you like a curve? Probably not. You only like it when it helps you. You don't like it when everyone does well. But that's what the whole point of a curve is to make it symmetric. Are we okay? So to backtrack a little bit, let's look at our dot plot. If you look at our dot plot, take a blanket, throw it on top. Take a blanket, throw it on top. It's not going to be perfect, but of the three shapes, which one does this look like? Symmetric. Why? Where's the majority of the data? In the middle. I would call this symmetric. Now, some people a little more really specific, they're like, oh, there's slight skewness to the left due to the 4. I wouldn't mark that wrong. You just have to justify yourself. But overall, where's the most of the data? In the center. So this would be what? Symmetric. So the dot plot would be symmetric. And I want you to write down the why. Why is it symmetric? Majority of the data is in the center. Majority of the data is in the center. Okay? Now we're going to look at the stem plot. When we look at the stem plot, I want you to turn it sideways. Take the stem plot, turn it sideways, throw a blanket on top. What shape would that be? Skewed to the right. What's causing the skew to the right? That 100. Now, if the 100 wasn't there, probably symmetric. But the 100 is there. So for shape, what are we going to put for stem plot? Skewed to the what?
Right.
To the right. And then I want you to put down y. In your own words, put down y. Okay? Now, on the next page, just real quick, and then I'm going to leave you with a big problem to work on at home. Not only do we have to worry about shape and center and spread, this one has one hump. One hump. That's unimodal. If it has two humps, that's called bimodal. Anything after 2, we call multimodal. Could have 3, 4, 5 humps. Okay? Now you probably ask yourself, why would there be more than one hump? I want you to think about, okay, it's 2017, you're going to start working out. You're going to start working out. Okay? Are you going to work out in the morning, the afternoon, or night? I want you to pick one. Only one. Morning, afternoon, or night. Okay? So raise your hand if you're going to work out in the morning. Okay? We have about a third of you. Raise your hand if you're going to work out in the middle of the afternoon. 2 people. Raise your hand if you're going to work out at night. About half of you. Okay? So what happens is a bunch of people in the morning, nobody in the afternoon, a bunch of people at night. That would cause what? 2 humps. Bimodal. That make sense? And then the last thing I'm going to talk about before I give you a big example is both of these pictures are symmetric. Both of them have the same center, but they're not the same. What's different about them? The top one is what? The top one is more spread out. The top one is more spread out. Even though they're both symmetric, they both have the same center, they don't have the same spread. The top one has more variability than the bottom one. The top one has more variability than the bottom one. So there's a lot of ways we can describe these pictures. Are we okay? So what I'm going to do for your last example, and this I want you to, we're going to start in class, and I want you to finish it at home. Because after I give this example, I'm going to take attendance, and I'll let you work a little bit. I want you to tell me how many hours a week do you work? Now, again, if you're a stay-at-home mom or a stay-at-home dad, or that's a great thing. But I'm looking for how many hours do you work at a job that gives you a paycheck, that sort of thing. And if you don't work, just say 0. There's no problem with not working. It's great. But I want to know how many hours do you work at like a part-time job or a full-time job? Okay, so how many hours a week do you work? 30. 0. 42. 25.
0.
0. 21. 30. 30.
0.
0.
Next. 0.
35.
35. 20. 40. 40. 0. 20. 32. 16. 26.
0.
2 more.
22.
22. Last one.
20.
20. Perfect. Now, before I let you loose working on this, we learned dot plot, we learned stem and leaf plot, and we learned histogram. Okay? You're going to make all 3, but before you make all 3, if I was going to make a dot plot, what would it look like? What to what? What's the lowest?
0.
What's the highest?
4.
42? And then you do 0, 1, 2, 3, 4, 5, all the way to 42. And you're going to have a lot of dots along the way? Probably not. Okay? So what I'd like you to do is I'd like you to make a regular stem plot. I'd like you to make a split stem plot. I'd like you to make a histogram in the calculator. Label everything. And then on the top, look up top real quick, answer these questions. Okay? So you can get started now. And I want you to use list 2, not list 1, not list 1. I want you to use list 2. List 2. Okay? So we have 10 minutes. I'm going to take you 10 minutes in a second. In list 2, you're going to put the data, make a histogram, make your regular stem plot, make your split stem plot. If it was me, since we have 10 minutes, make the histogram. Put the data in the calculator. See if you can get the histogram before you leave today in the calculator. Then you can go home and work on it. Okay? I'm going to call it 10 minutes in a second. I'm actually going to stop the recording.